The Webb peers such a long way out that it's catching light that has been voyaging for more than 13 billion years. However, the universe has been expanding, and thus the light has been stretching. For the most distant galaxies, we are looking back in time nearly to the Big Bang. The immensity of the universe might seem vast, but every last bit of it started from what we refer to as the singularity. As of now, this is how we interpret the Big Bang hypothesis. Anyway, the James Webb Space Telescope, JWST, has revealed significant secrets about the birth and evolution of the universe, leaving us bewildered. Famous physicist Brian Cox has proclaimed that the striking revelations made by the JWST might actually reshape our perception of the universe as a whole. Join us as we dig into these new divine disclosures that promise to upset our understanding. The James Webb Space Telescope, named after the distinguished NASA Administrator James E. Webb, stands as a wonder in current galactic investigation. This telescope represents a huge technological leap forward from its ancestor, the Hubble Space Telescope. Coming about due to a cooperative effort between NASA, the European Space Agency, and the Canadian Space Agency, the JWST surpasses the capabilities of its herald. It utilizes cutting-edge technology and a design optimized for studying the universe in remarkable detail. Unlike the Hubble, the JWST delivers clear and sharp pictures of distant heavenly bodies, working primarily in the infrared range. This unique feature allows it to penetrate cosmic dust and capture celestial objects that were previously hidden from our view. With its enormous 6.5-meter primary mirror made out of 18 hexagonal segments, the JWST dwarfs the Hubble's mirror in size. Situated roughly 1.5 million kilometers away from Earth at the second Lagrange point, L2, it orbits the Sun in a state of equilibrium with Earth, ensuring a stable and continuous view of the universe. While looking into the distant corners of the universe, exploring light years away also involves a form of time travel. The JWST uses infrared instruments to observe celestial objects and events going back billions of years. The light emitted by these objects, due to the expanding universe, undergoes a red shift, moving from the visible spectrum to the infrared range or longer wavelengths. Fortunately, the JWST can detect infrared light emitted by celestial bodies at extreme distances, enabling scientists to study the birth of stars, explore galaxy formation, and examine exoplanet atmospheres. Its latest notable discovery includes identifying an enormous mass of galaxies at the edge of the observable universe. This finding challenges the validity of the Big Bang theory, prompting a reassessment of our central cosmological assumptions. To better understand how we arrived at this point, let's take a brief journey through the history of space exploration. Early civilizations, like the Greeks and Chinese, laid the foundation for understanding planetary motion by observing celestial bodies. Newton's laws in the 17th century provided a theoretical framework for space travel. In the early 20th century, Edwin Hubble, an influential space expert, made historic discoveries in cosmology and observational astronomy. His observations revealed that distant nebulae were separate galaxies far beyond the Milky Way, changing our understanding of the universe's size and expansion. Hubble's law, formulated by him, showed that galaxies farther away were moving away at higher speeds, providing evidence for the expansion of the universe. The post-World War II period marked the beginning of the space race, with the Soviet Union's Sputnik in 1957 as the first artificial satellite in orbit, Yuri Gagarin's orbital flight in 1961, and the Apollo 11 moon landing in 1969 as landmark achievements. Fast forward to 1990, when the Hubble Space Telescope, HST, was launched, providing exceptional clarity and stunning insights into the universe. The journey from ancient observations to the technological wonders of the James Webb Space Telescope highlights the steady development of our understanding of the universe. The Hubble Space Telescope captured the famous Pillars of Creation image in the Eagle Nebula, revealing a stellar nursery formed by massive columns of gas and dust. Another key achievement was the Hubble Deep Field, capturing thousands of galaxies in what appeared to be an empty patch of space. The HST also delved into exoplanet atmospheres, pinpointing elements like water and organic molecules on distant worlds, hinting at the possibility of habitable zones. Beyond our solar system, following the discovery of the closest observed supernova, SN 1987A, it shed light on the life cycle of massive stars. These accomplishments cemented the Hubble Space Telescope's legacy as a foundation of modern space science, captivating the world with its astounding astronomical discoveries. Its successor, the James Webb Space Telescope, JWST, was launched to build on technological advances and lessons learned from Hubble. One example is our understanding of the universe's origins, which today is explained by the prevailing theory of the Big Bang. Around 13.8 billion years ago, the universe began as a hot and dense singularity, rapidly expanding and giving rise to matter, energy, and fundamental forces. As the universe expanded, it cooled, leading to the formation of atoms, stars, galaxies, and the various structures observed today. The Big Bang Theory also explains cosmic microwave background radiation, light element abundance, and the large-scale structure of the universe. Despite being widely accepted, the Big Bang Theory faced skepticism and challenges in its early years. Alternative models, such as the steady-state theory, proposed a universe without a specific beginning. Concerns arose about evidence supporting the initial singularity, the expansion mechanism, and observed anomalies. Many of these issues were addressed over time, with a critical piece of evidence coming with the detection of cosmic microwave background radiation in 1965, aligning with Big Bang predictions. Space missions like COBE and WMAP, alongside technological advances, further supported the theory. Precise measurements of cosmic microwave background radiation match theoretical predictions remarkably well. Enter the James Webb Space Telescope. Equipped with advanced infrared instruments capable of peering through cosmic dust clouds, it operates primarily in the infrared range. The JWST captures the oldest light in the universe, observing objects formed shortly after the Big Bang. Its infrared capabilities allow it to focus on star-forming regions, stellar nurseries, and the birth of stars, which are obscured from optical telescopes. Infrared light, with longer wavelengths than visible light, penetrates interstellar dust clouds, overcoming a limitation of the Hubble Space Telescope. The JWST can detect cooler objects emitting primarily in infrared, making it ideal for studying phenomena like exoplanets, brown dwarfs, and distant galaxies. As celestial bodies move away, the emitted light stretches, causing a redshift. The JWST's infrared capabilities detect these redshifted signals, capturing light from the early universe and offering insights into its formation and evolution. Exciting events, like black hole formations or new starbursts, predominantly emit in the infrared range, further expanding the JWST's observational capabilities. The telescope complements optical telescopes like Hubble by offering enhanced sensitivity and the ability to detect infrared radiation. This capability allows it to peer deeper into space and delve further into cosmic history, revealing hidden cosmic wonders and offering a broader perspective on the universe's development. The JWST serves as our window into the earlier stages of cosmic evolution. Recently, it uncovered something so astounding that it might prompt a reevaluation of the entire cosmological model of the universe. It discovered vast masses of galaxies at the very edge of the observable universe. These ancient galaxies existed only a few 100 million years after the Big Bang, settling at the cosmic dawn. The astonishing part is that we're unsure how such massive structures formed so early in the universe's history. This discovery may lead us to reconsider our understanding of the formation and evolution of galaxies in the early universe. Studying early galaxies is crucial for unraveling the mysteries of cosmic beginnings. The JWST can provide insights into how galaxies, stars, and planetary systems emerged and evolved over billions of years. These observations also contribute to broader questions about the fundamental nature of the universe, including its composition, structure, and the forces governing its expansion. While the Hubble Space Telescope was groundbreaking for its time, it had limitations in observing the early universe. Its primary constraint was its inability to effectively penetrate cosmic dust and detect the infrared light emitted by ancient galaxies. Older telescopes relied on visible and ultraviolet light observations, making it challenging to explore the early universe, where these wavelengths are absorbed or distorted by cosmic dust and gas. The James Webb Space Telescope represents a remarkable leap in observing galaxies from the universe's earliest stages. Unlike its predecessors, the JWST can observe celestial objects that formed within a few 100 million years after the Big Bang. Using its infrared sensitivity and advanced imaging capabilities, the JWST has revealed an abundance of ancient galaxies, offering unprecedented clarity and detail in understanding the universe's evolutionary history.